Okay, in this video we're going to be finding formulas for linear functions, and we're going to be looking at three different types of examples. The first type is we're going to be finding a formula given a table of data. The second type we're going to find a formula given a graph. And the third type we're going to find a formula given just a verbal description of a situation. So let's take a look at this first example. It says a baseball is thrown straight up into the air by a person standing on the ground. Its velocity, v, is a linear function of t, the time since it was thrown. And we want to try to find a formula for this, the velocity of this baseball as a function of time, given these data in the table. So the first thing I recognize, actually before I do that, let me go ahead and sketch what this, what a graph of this function is going to look like. And I notice that if t is my independent variable, that's time, and v is my dependent variable, the velocity, and I've got 0, 1, 2, and 3, so 0, 1, 2, and 3, those are my time values, 0 seconds, 1, 2, and 3 seconds. And if I graph each one of these points here for velocity, point 0, 48, it's going to put about right here. Point 1, 16, let's say, is about right here. 2, negative 16 is about right here. And then 3, negative 48 is going to be about right here. So my graph of my function is going to look something like this. All right, so I notice it has a negative slope, so my slope should turn out to be negative. And I also notice that I already know what my vertical intercept is. My vertical intercept is this point right here, which is 0, 48. So I know what this point is. I know the coordinates of my vertical intercept. So given that I know what my vertical intercept is, it makes sense for me to use the slope-intercept form of the equation of the line. So y equals mx plus b. I already have this value here. I know my vertical intercept. If I can just come up with the slope, then I can plug those values in and I'll have my equation. Well, since I have 4 different points here, I can pick any 2 of those points and I can calculate my slope. Remember, slope is just delta y over delta x, or often we write the slope formula as y2 minus y1 over x2 minus x1. So if I just pick 2 points here and plug those values in, I should get my slope. Well, how about if I use these 2 points here? So let's see. Y, that's my dependent variable here, which is velocity. So let's see. Let this be y2 and y1, and this will be x2 and x1. So let's see. y2 minus y1 is going to be 16 minus 48, and x2 minus x1 is going to be 1 minus 0. So let's see. 16 minus 48, that's going to be negative 32 over 1, which is negative 32. So now I have my slope. Well, I have my slope, I have my vertical intercept. My vertical intercept is this value 48. Well, I can just plug those values in and I'll have my equation. Y equals, m is negative 32, y equals negative 32x plus my vertical intercept, that value is 48, and there is my equation for this function. Actually, I think I want to write this, since my variables are t and v instead of x and y, let me go ahead and write this in terms of t and v. So my dependent variable is not y, it's v. So velocity equals negative 32 times time, my independent variable, plus 48. And there's my equation. All right, part B says, what does the vertical intercept tell us about the baseball? Well, my vertical intercept, that's this point right here. My vertical intercept just tells me the value of the function at its initial point. In other words, the value of the function when my independent variable is 0. So what this tells me about the baseball is that at time t equals 0, when I first throw the baseball up in the air, the velocity, its initial velocity, is 48, and that I believe is in feet per second. So essentially this just tells me, what does it tell me about the baseball? It tells me the velocity of the baseball let's say, at time t equals 0. And part C, what does the average rate of change, that is the slope, tell us about the baseball? Well, we already noted that our slope is negative, which means that the rate of change of the velocity is negative, and that just tells me that my baseball is, the velocity of my baseball is constantly decreasing. In other words, from the time that I let go of the baseball, I throw it up in the air, the velocity of the baseball begins to decrease because gravity is pulling down on the baseball. So this just tells me that the velocity is decreasing. And not only is it decreasing, but since this is a linear function, my velocity is decreasing at a constant rate. Okay, example number 2, finding a formula from a graph. The following graph shows the heights of 2 women as a function of their forearm length. So I have these 2 women, and one of them has a forearm length of 23 centimeters, and the other one has a forearm length of 28 centimeters. And I can see the height of one woman is 160 centimeters, and the height of the other woman is 170 centimeters. And it says, assuming the relationship between height and forearm length is linear, find a formula for this function. And now, notice it says, hint, use the point-slope form of a line. Well, notice that for this particular example, I don't know what the vertical intercept is of my function. I don't have a data point that's over here on the vertical axis. So it's not going to be very useful to try to use the slope intercept form because I don't know what this intercept point is. I can, however, use the point slope form. And remember, the point slope form of the equation of a line looks like y minus y1 equals m times x minus x1. Well, if I have a point and a slope, then I can just plug my point and my slope into this form, and I can come up with my formula. Well, I have a point. In fact, I have 2 points, so I can use either one of those points in my equation. Now I just need to come up with the slope. Well, my slope, again, is just delta y over delta x, and I can use these 2 points to calculate my slope. So let me call this x1 and y1, and I'll call this x2 and y2, and I can just plug these values in and calculate my slope. So this is going to be y2 minus y1 over x2 minus x1. Let's see, y2 is 170, y1 is 160, and let's see, x2 is 28, and x1 is 23. So this gives me 10 over 5, and my slope, the value for my slope then is 2. So I'm going to use this value to plug into here. So let's see, I need one of my points, and let me see, how about if I choose the point, I'll just choose this point right here. So let's see, I've got my point slope form, y minus y1, so y1 will be 160, equals m, and my m value is 2, times x minus x1, my x1 value is 23, and now I have a formula for my function. Now I want to go ahead and put this into slope-intercept form because that's the most useful form of the equation of a line. So let's see, let me do a little bit of algebra here. I'll use my distributive property. That gives me 2x minus 46. And let's see, if I add 160 to both sides, then that gives me y equals 2x. This is going to be plus 116.46. That's going to be 114. Yep. And so now I have my equation, or my formula, for this linear function. Part B says, based on this formula, what would you expect would be the height of a woman whose forearm is 24 centimeters long? Well, I don't have data on my graph for a woman whose forearm is 24 centimeters long, but based on this formula that I just came up with, a woman whose forearm is 24 centimeters, that would be about right here. And so her height would be about right here. Well, if her forearm length is 24, I can just plug that value in for x, that's my independent variable, and I can calculate what her height would be. So y equals 2 times x. X in this case is 24. So 2 times 24 plus 114. That gives me 48 plus 114, which is 162 centimeters. So I would expect that a woman whose forearm is 24, based on this model, I would expect that a woman whose forearm is 24 centimeters long has a height of 162 centimeters. Okay, example number 3. This is an example of finding a formula from a verbal description. So we have $24 to spend on chips and drinks for a party. A 6-pack of soda costs $3 and a bag of chips costs $2. And I want to come up with an equation, a formula that relates the costs of these two items so I can figure out how much I have to spend on chips and soda for my party. So these verbal descriptions, a lot of times there's not a single way to go about coming up with the equation, but we can at least get started on this one. I want to note a couple of things. First, let's note that the number of 6-packs I can buy depends on the number of chips that I buy. The more chips I buy, the fewer 6-packs of soda I could buy, or the more soda I buy, the fewer 6-packs of chips that I could buy. So these two things depend on each other. So I could say the amount of soda I buy is a function of the number of bags of chips that I buy. Or I could also say the number of bags of chips I buy is a function of the number of 6-packs of soda I buy. So this could go either way in this case. All right, the second thing I want to note is that since I have $24 to spend, $24 is going to be the amount of money I spent, the amount of money that I spend on soda plus the amount of money that I spend on chips. So now I kind of have the makings, I have the beginnings of a formula here. $24 equals the money I spend on soda plus the money I spend on chips. Well, how much money am I going to be spending on soda and how much money am I going to be spending on chips? Well, let's see. The amount of money that I spend on soda, let's see, if a 6-pack of soda costs $3, then the amount of money that I spend on soda is going to be 3 times however many 6-packs of soda I buy. So we'll call that 3 times S. How much money am I going to spend on chips? Well, if a bag of chips costs $2, then the amount of money that I spend on chips is going to be $2 times the number of bags of chips I buy. So that's going to be 2 times, if I call C the number of bags of chips that I buy. Then the amount of money I spend on chips is going to be 2 times C, $2 times the number of bags of chips that I buy. Well, so now I've got some algebraic expressions for the amount of money I spend on soda and the amount of money I spend on chips. Well, I can plug these in here, and all of a sudden now I've got something that looks like an algebraic equation. So I'm going to let you finish this one on your own, and we'll take a look at this in class tomorrow.